Hey guys, welcome back. Today we are continuing our lessons in stoichiometry and we are learning about a concept called molar mass. So definitely more conversions on the horizon today. If you did not do your first lesson, please go back and do that ASAP because this one builds on it. This is not a kind of unit where you can just do the lessons individually. You're going to have to do them in order or else it will make zero sense. So with that caveat out of the way, let's go ahead and get started. So really quickly, we need to make sure before we get started in this lesson today that we remember where to find the average atomic mass for an element. So it's going to be on the periodic table. Sorry, I was searching up something earlier. So on the periodic table, when you take a look at a element box, right, we have our atomic number on the top. So for lithium here, the atomic number is 3. That tells us the identity of the element and the number of protons in the nucleus. And then the average atomic mass, which is the average of all the isotopes of that element, is on the bottom, and it's the larger number, so 6.94. So that means on average, the average atomic mass of lithium is 6.94 grams. Okay, so that lets us know the average atomic mass. That's going to be important because sometimes in these problems that you're going to be given, you won't be given the average atomic mass. You'll have to find it from the table. So just a refresher on where to find that information. Okay. So let's talk about what we're going to be talking about today and how it relates to what we learned yesterday. Okay. So most of the time, we can't actually count the number of particles in an element or a compound. So if you have sodium chloride, lithium, whatever, you're not going to be able to, dump it out on the table and count how many particles there are. It's impossible, right? Because we can't really separate those particles and count them. They're not visible to the naked eye. But what we can do is we can use the mass of that element or compound to determine the particles, because we already know how to relate moles to particles, right? 1 mole is equal to 6.022 times 10 to the 23rd particles. And today we're going to be able to relate moles to grams, which will pull it all together. So molar mass is going to be basically the mass of 1 mole of an element. Okay, or 1 mole of a compound, depending on what we're working with. So to find particles, using mass, we're going to be looking for the molar mass. And the molar mass is just the mass of 1 mole of a substance, aka the molecular weight in grams. That comes from the periodic table. So we were looking at lithium before. So let's go back really quick. So 6.94 was the average atomic mass of lithium. That means 1 mole of lithium is equal to 6.94 grams. Okay, just like with our mole yesterday, where it's a unit of measurement, this is going to tell us how many grams are in 1 mole of an element. Okay. However, we know in chemistry, we're not dealing with just elements. Okay, so sometimes we'll have to calculate the molar mass of compounds, right? So for example, here we have sodium chloride. In order to do that, what we're going to do is we're just going to find the average atomic mass of each of those elements, and then we're going to add them together. Okay, so here we have sodium chloride. This is where also counting atoms comes back into play. We've got 1 sodium and 1 chlorine. So we're going to need to find the mass of each of those. So sodium is 22.990 and chlorine is 35.45. Okay, and we are just going to add those together to find our molar mass. Okay, so 22.99 plus 35.45 is going to give us 58.44 grams. So what this means is that the molar mass of sodium chloride is 58.44 grams. So 1 mole of sodium chloride is 58.44 grams, and that also means that 1 mole of sodium chloride is 6.022 times 10 to the 23rd particles. Okay, so in a laboratory, if this will help you visualize it, let's say that you go to the scale and you have a bottle of sodium chloride and you weigh out 58.44 grams, okay? You could take that little pan of sodium chloride that weighs 58.44 grams, and you could also say this is 1 mole of sodium chloride. So if you had 58.44 grams, you would know that you had 1 mole. You also know that you have 6.022 times 10 to the 23rd particles there. So without having to, get a, impossible microscope and count out individually all those particles, you could know that there's 6.022 times 10 to the 23rd based on the weight. Okay, so basically what we're doing is we're adding an extra step to what we did yesterday. So yesterday we learned how to convert moles to particles and vice versa. Today we're going to take it one step further and convert moles to grams, and also we can convert particles to grams as well. Okay, and again, this is just what this means. So we can relate moles to particles because we know that 1 mole is equal to 6.022 times 10 to the 23rd particles. And now we also know how to relate moles to grams. So 1 mole is equal to the molar mass in grams. Again, you might have to calculate the molar mass, but that just comes from the average atomic mass on the table. Okay, let's do a practice problem. So this is going to be a conversion factor. So again, we're setting up either our fractions or our T-chart, however you prefer to do it. So how many grams are in 2.56 moles of lithium? Well, the first thing I'm going to do is I'm going to go back to my table really quick and look for lithium. Lithium has an average atomic mass of 6.94 grams, so I know I'm going to use that as my molar mass, okay? Sometimes it will be given to you in the problem, sometimes you'll have to use the table. So let's look at the steps for solving this. Number 1, we're going to write down what we're given. Number 2, we're going to determine what we're converting to. We are going to set up the units so that they cancel properly. We're going to add our numbers based on our conversion factor. And then we are going to solve. So go through and just do the math. Remember, when we're doing these fractional problems, multiply through the top first, then multiply through the bottom, and then divide at the end. It's the easiest way to do it. Okay, these are the same steps as what we did yesterday, but instead of just converting from moles to particles, today we're doing moles to grams. Okay, so let's start with what we know. We always start with what we're given, then our conversion factor of our unknown and our given. So we're starting with 2.56 moles of lithium, right? Now I have to decide where my units go on the right-hand side. We want to get rid of moles, and we want to be left with grams. So I know my moles are going to go on the bottom so that they'll eliminate, and my grams will go on the top. The unit that you want to be left with always goes in the numerator, okay? Always goes on top. If we want to end with grams, it's got to be on the top, okay? Now, here's where we do our conversion factor. Just like with the particles yesterday, when we do our conversion, the 1 will always stay with the mole, okay? Because 1 mole will be equal to something. Here, the mole is going to be equal to the molar mass of lithium, which comes from the average atomic mass, right? Which we already determined was 6.94. So, we're going to put the 1 on the bottom. Our moles are going to eliminate, and 1 mole is equal to 6.94 grams of lithium. That comes from the periodic table, okay? The average atomic mass is equal to the molar mass of individual elements. Now, if this was like a compound, you would have to add those average atomic masses together, but since we're just doing one element here, the molar mass is going to be equal to the average atomic mass. Okay, so 1 mole is equal to 6.94 grams. And there you have it set up. Your moles are going to eliminate, and you're going to be left with grams of lithium. And let's go ahead and see it on the next slide about how you go through. Okay, so this is how you can show it in a fractional way. So we have 2.56 moles times 6.941 grams, and this wasn't rounded, so this was a from a different table. It doesn't matter because as long as we get close to the answer, it'll be fine. So our moles eliminate. And since this is a fractional problem here, you don't have to do anything on the bottom because we would just imagine that this 2.56 moles sits over 1. So 1 times 1 is 1. So we don't have to worry about the bottom. So all we have to do here is multiply through. So 2.56 times 6.941 would give us 17.76896, which we just round to 17.77 grams of lithium. So that means 2.56 moles of lithium weighs 17.77 grams. So if you were to measure out on a little scale 17.77 grams of lithium, it means you have 2.56 moles of lithium. Okay? So now let's do another example. So here's the thing, is that it's not always going to be a one-step conversion. Now that we're learning how to convert these, moles to particles and then to grams, there can be multi-step conversion that you have to do. And now we can do that. So not only can we go from moles to particles and moles to grams, now we can go from particles to grams. And we can do that by first converting from particles to moles and then moles to grams. Okay, so again, everything in this unit is going to build on itself. So you have to do these lessons in order. And if you're not getting it, we need to set up a tutoring session. Okay. So here's a question. It says, how many grams of carbon must Mrs. Cone have if she sells 3.45 times 10 to the particles of carbon? So here we're starting with particles and we want to end up with grams. There's not a conversion factor that relates particles to grams. Okay, so we're not going to be able to go straight from particles to grams. We're going to have to do a two-step conversion. So we're going to have to go from particles to moles and then from moles to grams. So let me show you what this looks like. Okay, so we start with what we know, 3.45 times 10 to the 21st particles. And then we know we want to get rid of our particles, so that goes on the bottom, and our moles will go on top. Okay, now again, with any conversion factor, the 1 is going to go with the moles. And then how do we relate moles to particles? Well, that's going to be with Avogadro's number always. So 1 mole will be equal to 6.022 times 10 to the 23rd particles. Okay. We don't want our answer in moles though, so we have to keep going. Okay. Once our particles are eliminated, we'll be left with moles. And then we can do the step where we go from moles to grams. So now we'll put our moles on the bottom and our grams on the top. Again, we'll put a 1 with the mole. And how do we relate moles to grams? Well, we know we can do that with molar mass. So we're going to find the average atomic mass of carbon from the periodic table and plug that in. Okay? So our particles will eventually eliminate, and then our moles will eliminate to give us our grams. So let's take a look at this math here. We start with 3.45 times 10 to the 21st particles times 1 mole over 6.022 times 10 to the 23rd particles. The particles will eliminate times 12.01 grams over 1 mole. Our moles will eliminate, and we will be left with grams. Okay, that's exactly what we want. We want to go from particles to grams. And our answer here will be 0.069 grams. So to plug this into the calculator, also, I don't know why there's not a unit here. You never want naked numbers in chemistry. But just to give you an idea of what you would plug into Desmos, so we would multiply across the top first. So we would do 3.45 times 10 to the 21st times 1 times 12.01. Okay, so you would do that first. Then you would divide everything by 6.02 times 10 to the 23rd times 1. Okay, and then that would give you 0.069. I would encourage you to type that into Desmos and see if you come up with that 0.069, and if not, we need to look at how we're putting it into the calculator. Okay, these problems are going to take practice, and of course, If you're still confused, let me know and I will meet with you and do some problems as well.